Welcome to Jackson's Maths channel. Maths made simple. From my first video and onwards until the end of CXC, I'll be targeting multiple choice questions. For you to do multiple choice, you have to have certain strategies, and I'll be showing you tips and also working out multiple choice questions. We'll be looking at some CXC model questions and also actual CXC questions. Now our first question is, the number 5.17604 correct to three significant figures is, and these are the choices. The choices run from A to D. Now first, you would look at the original figure here, which has 1, 2, 3, 4, 5, 6 significant figures. Now it is of note that every digit from 1 to 9 is significant. Now, here we have a 0. Now what about 0? Zeros on their own are not significant. So if we have the figure 600, then these two zeros are not significant because they are on their own. So we would have only one significant figure here. But if we have 601, then this 0 is significant because it comes between two significant figures. And so we have 1, 2, 3, 4, 5, 6 significant figures here. Now, writing it correct to three significant figures, we want only 3 digits, essentially. And we normally work from left to right, from our first non-zero digit. So this is our first non-zero digit, which is 5, which is a whole number, followed by a decimal point, which separates a whole number from the decimal fractions. So this is 0.1, which represents 1/10. This is 700. So we'll have 1, 2, 3 figures so far. But what we have to do is to look at the fourth digit, which is 6. And the rule is, if the digit that you're going to throw away or discard is 5 or more, then it will increase the digit before it by 1. Hence, we throw away the 6, and so the 7 will be increased to 8. Hence, this is our answer. Okay, number 2, the set of factors of 16 is. First, you need to know what a set is. A set is a collection of items, objects, or things that usually share things in common. And a set is represented by curly brackets. Now here we have factors. What exactly is a factor? Now a factor is a number that can divide exactly into that number. In other words, no remainder will be left. So we want numbers that can divide exactly into 16. Now it is of note that you need to know that every number is a factor of itself along with the number 1. Because factor times factor equals multiple. And so we look at 16 as our multiple. So we know that 16 times 1 will equal 16. So factor times factor equals a multiple. Now, so if we look at B here we have 16. Yes, this element or member of this set would be a factor of 16. Unlike 32 and 48. Because 32 cannot divide exactly into 16. Because what we want are really whole number multiples and not fractions. And so what happened here is that 32, 48 are actually multiples of 16 and not factors of 16. So this cannot be our answer. When we look at 3, 6, 9, 18, we know that 3 is not a factor of 16 because based on our timetable, 3 times 5 will give us 15. Hence, 3 is not a factor of 16 because a remainder will be left. Another thing that you need to know is that, okay, based on the divisibility rule, for 3 can go into any number exactly if the sum of the digits of the number is divisible by 3. So we know that, say 3 5s is 15. What are the digits? 1 and 5. So when I add 1 plus 5, I get 6. And 6 is divisible by 3, goes 2 times. If we try another one, let us say 36. 3 plus 6 is 9. 9 divided by 3 is 3. So these numbers, 15 and 36, are really multiples of 3, because when you add the digits, the sum of the digits is divisible by 3. Unlike 16, because 6 and 1 is 7. So when I divide 7 by 3, it's not an exact figure. And therefore, 3 cannot be a factor of 16. So we need not go any further. And when we look at D now, 1, 2, 4, 8, 16, 1 and 16 are already factors. 2, which is an even number, can go into 16. 2 can go into 16 8 times, and 4 can go into 16 4 times. So these are all the factors of 16. Now, which of the following is equivalent to 34 times 997? Now, equivalent here essentially means having the same value, even though the form may look different. So this is 34 times 997. Now, what we need to do, based on what you are seeing here, we have to manipulate this number 997 to get the difference of two numbers. Now, two numbers that actually differ to get 997 are really 1003. So we know that 1000 minus 3 is actually equal to 997. However, when we look at A, for multiple choice questions, generally speaking, you get two answers that are very close. No, so A and B cannot be our answers, because here what we have is 100 minus 3. That gives us 97. But what we need to have is 997. So when you look at C and D, here we have 1000 minus 3. Here we have 1000 minus 3. But what is the difference? Now when we look at C, C has 34 times 1000 minus 3. Now, students may opt for this answer, but is this answer correct? No, this answer is wrong. Why? Because based on the rules of BOMDAS or BODMAS, we know that multiplication must be done before subtraction. So multiplication must be done before subtraction here. And so you'd have to multiply 34 by 1000, which actually gives us 34,000. Then you subtract 3, which is different from D, in which D is 34 times 1000 minus 3, which is making use of what we call the distributive law, or the distributive property. So right here, we have a pair of brackets enclosing the difference between 1000 and 3. So when we take 3 from 1000, we actually have 997. And the bracket, whatever is outside the bracket, here is telling us to multiply to what is on the inside. So right here would be 34 times 997. Hence our answer is D, and you circle D. Now remember, you have to work speedily, accurately, and meticulously when doing the multiple choice. Number 4. When doing multiple choice, ensure that you read the question very carefully. So, a salesman is paid 6% of his sales as commission. His sales for last month was $5,080. What amount of money was he paid as commission? So read the question fast. However, pay attention to important details or important concepts. So watch this. 6%. We know that percent means out of 100, because a percent is a fraction that has a denominator of 100. So 6% is really 6 over 100. Now it is said that he gets paid 6% of his sales as commission. Now what exactly is commission? Commission essentially is a percentage of a certain amount of sales that a person would work. And so commission is usually X% of the total amount of sales. So what you get here is that the sales for last month is $5,080. So it is 6% written as 6 over 100 of $5,080. Of in maths means to multiply, and you write down the multiplication sign quickly, $5,080. Now remember, you don't have access to a calculator. So how do we go about this? What we can say here is that 0 cancels 0. Now what exactly does 0 cancel 0 mean? It doesn't mean that 0 divided by 0 equals 1, because this cannot be determined. You cannot divide by 0. So what it is really saying when it says 0 cancels 0 is that 10 divided into 100 goes 10 times, and 10 into 5,080 goes 580 times. So what we simply do as a shortcut, we just cancel out these. Now, when divided by 10, 100, 1,000, etc., there's a shortcut method. So instead of using 2 here, we could quickly multiply 6 by 508. Now remember, you don't have a calculator, so you have to know your timetable. So 6 8 is 48, 8 carry 4, 6 0 is not. Add the 4 that you carry here, it is 4, 6 5 is 30. So what we have is 3,048, and you are going to write very quickly divided by 10. Now, in multiple choice, there's a shortcut of doing stuffs, which if you are doing it in the long paper, there's something called concepts that you have to stick with. But in multiple choice, you need strategies. Now, when dividing by 10, you simply shift, for the shortcut, shift the decimal point, which is at the end of the number, one place to your left, to get 304.8. Now, as I said, is a shortcut method, because normally we don't shift the decimal point. It's the digits that actually shift around the decimal point. So we have 304.8 divided by 10. We do this and we get 304.8. But 0.8 of a dollar, 100 cents make a dollar. So essentially 0.8 is 1/10 of 100 cents, which is the same thing as a dollar. So 10 into 100 is 10, so 10 8 is 80, so it's really $304.80 that we actually have. And so we check for our answers. As a matter of fact, the answers were A, $304.80, B, $30.48, C, $2.54, D, $25.40. And so we see here that our answer is A. No, number 5. A ship sailing on a bearing of 135 degrees is traveling A, northeast, B, northwest, C, southeast, D, southwest. Now the first thing that you need to do here is to draw up your north line. Actually, you can draw your cardinal points. So you see something like this. You put your north, you put your east, you put your west, you put your south, and show arrows that indicate the direction. Now bearings are special angles measured from north in a clockwise direction, and bearings must always have 3 digits. Hence, from north you'd basically have 0 degrees, because we start from 0 degrees here. Now we know that east is a bearing of 90 degrees. Now if east, south, west and north divide a circle into 4 equal quarters, where each quarter is a quadrant, then it simply means that a quarter of the 360 degrees must be 90 degrees. So east has a bearing of 90 degrees. What they want here is what direction our bearing is 135 degrees. Now, since east to south, or this quadrant here as an angle of 90 degrees inside here, then if we find a half of 90 degrees, That's actually 45 degrees. So from here to here is 45 degrees. And so a bearing of 135 degrees will include 90 plus 45 degrees. So this would actually be our bearing, which is 135 degrees. Now, what direction is this? Now, if this is east and this is south, then the direction between south and east is actually southeast. And so you tick C or circle C as southeast. Now, number 6. Here we have the set, because the curly brackets here indicates the set or the set of. So in set notation, let us read it, because here set has its own language. So mathematics has its language and each topic has its language. So here we read this as the set of x such that x is greater than 4 but less than or equal to 9, where x is a member, because this symbol here means is a member of z, but z represents the set of integers. So what we want is numbers greater than 4. But remember, we are actually looking at integers, which are the positive and the negative of the whole numbers. Because whole numbers represented by the letter W actually begins from 0, going 1, 2, and go up. We also have what we call n, which represents the natural numbers or the counting numbers, which starts from 1 going up. Now, once we use 3 dots, it means and so on. So here you need to recognize that n, which is a set of natural numbers, is a subset of the set of whole numbers. The only difference is that 0 is included in the set of whole numbers, while it is not included in the set of natural numbers. Now, the set of integers now include the set of whole numbers here along with their negatives. So, a number or an integer greater than 4 would actually begin from 5, because we cannot have any fraction. So we can't have 4.5, 4.1, etc. It has to be a whole number. So it goes from 5, then 6, then 7, then 8. Now here what we are seeing is that x must be less than, less than 9, but at the same time it can be equal to 9. So therefore the set can actually go right up to 9. And so we enclose these elements by using our curly brackets. And so we check for our answer, and our answer is 5, 6, 7, 8. Oh, I missed out this one. And 9. Sorry, I didn't write that here. So 9 should be a part of that. So our answer is C. Now, number 7. A girl scored 80% on a test. 80% on a test simply means that she didn't ace the exam by scoring everything. She got some wrong, because if she had aced the exam, she would have got 100%. So it follows that she didn't get the full marks. So if the maximum number of marks possible was 20, clearly indicating that she didn't get the full 20 marks, then she scored. So what we need to find is the percentage of the full marks that she got. So we write quickly 80% of the 20, which is 80 over 100 times 20. And you have to work very fast. 0 cancels 0, 0 cancels 0, and we simply say 2 8 is 16. And as you get 16, you look if your answer is there, okay, yes, and you circle D. And you move to the next question. Number 8. Which of the following functions could describe the mapping shown below? Okay, when you hear about a function, here when you hear about a mapping, what exactly is a function? First, a mapping basically is a relation which shows a connection between two quantities. Now, usually in maths we tend to use x and y. So how x is mapped onto y? So what relation maps x onto y? Now, for it to be a function, a function known is a relation in which each x value is mapped or paired onto only one y value. Now for this, we look here. What you need to look at is where the arrow is arriving. Where the arrow is leaving, we refer to those numbers as a part of the domain. So it's like, what we could do is to use a mapping diagram here, and we'll have like the domain and what we call the range. So the domain is a set of x values, the range is a set of y values. So here we have 0 being mapped onto 1, 1 being mapped onto 2, 2 here being mapped onto 4, 3 being mapped onto 8. So what we need now is a relation that maps x onto y. Now this is read as f, we see f colon x with our mapping onto x plus 1. So this is read as f of x being mapped onto x plus 1. You could have also seen f open bracket x equals x plus 1, saying the same thing, which is a function in x which maps onto x plus 1. So right here, 0 is being mapped onto 1. Now if we check to see this relation here, x plus 1, let us say x is 0. Now when I add 0 to 1, here I get 1. So you might say that this is our answer. But the relation must hold true for all the values. So if I check 1, good. Anywhere I see x, I put 1. So it's 1 plus 1, which gives us 2. So you might jump to the conclusion that this answer is correct. But please check to see the others. Let us look at 2. Now if x is 2, 2 plus 1 is 3. But what we have here is 4. So clearly this relation is not our answer. Then we check f of x maps onto x plus 2. Now if x is 0, 0 plus 2 actually is 2, but our answer here, we need to get 1. So this is clearly not correct. Now f of x maps onto 3 raised to the power of x. Now 3 raised to the power of x, x here being 0 is 3 to the power of 0, which is really 1. So this holds true. But 3 raised to the power of 1 is saying that we have just 1 3, but the answer here is 2. So this is incorrect. So it cannot be 3 to the power of x. So our answer clearly then is 2 to the power of x. But we could also prove it. Because 2 raised to the power of x, x here being 0, any quantity basically raised to the power of 0, except for 0, is really 1. And so, here we have 2 to the power of 1 equals to 2, and 2 to the power of 2 is 4, and 2 raised to the power of 3 is 8, because the index or the exponent here indicates that 2 must be multiplied by itself 3 times. So it's 2 times 2 times 2, which gives us 8. So therefore D is our answer. Now number 9, the area of the shaded region of the parallelogram. Now here we have a parallelogram. Now properties of the parallelogram. A parallelogram is a quadrilateral, and a quadrilateral is a polygon that has 4 sides. Now this side is parallel and equal to this side in the parallelogram. This side is parallel and equal to this side. Now this line that runs from one opposite vertex to the opposite to another vertex over here is called the diagonal. Now what the diagonal does to the parallelogram is to cut it into 2 triangles. Now if we want to find the area of the shaded region, you simply realize that the part shaded is actually a triangle. Now we know that the area, or you need to know that the area of a parallelogram is base times height. So we can regard this as a base. Now right here is 5 centimeters, but this is not the height. The height has to be perpendicular with the base. And so the perpendicular height is 4 centimeters. So the area of the parallelogram would simply be base times height, which is 15 times 4. And that would be in square centimeters. But what we actually have here is the area of the triangle. Now you would have learned that the area of a triangle is a half base times height. Now you see the relation between the area of a triangle and the area of a parallelogram. Because what happens is that the triangle here has the same height as the parallelogram and the same base. And that is why the area of the triangle is half base times height. And so what we do know is half of 15 times 4 is really 15 times 4. Now number 9, the area of the shaded region of the parallelogram. Now here we have a parallelogram. Now properties of the parallelogram. A parallelogram is a quadrilateral, and a quadrilateral is a polygon that has 4 sides. Now this side is parallel and equal to this side in the parallelogram. This side is parallel and equal to this side. Now this line that runs from one opposite vertex to the opposite to another vertex over here is called the diagonal. Now what the diagonal does to the parallelogram is to cut it into 2 triangles. Now if we want to find the area of the shaded region, you simply realize that the part shaded is actually a triangle. Now we know that the area, or you need to know that the area of a parallelogram is base times height. So we can regard this as a base. Now right here is 5 centimeters, but this is not the height. The height has to be perpendicular with the base. And so the perpendicular height is 4 centimeters. So the area of the parallelogram would simply be base times height, which is 15 times 4. And that would be in square centimeters. But what we actually have here is the area of the triangle. Now you would have learned that the area of a triangle is a half base times height. Now you see the relation between the area of a triangle and the area of a parallelogram. Because what happens is that the triangle here has the same height as the parallelogram and the same base. And that is why the area of the triangle is half base times height. And so what we do know is half of 15 times 4 is really 15 times 4 divided by 2 square centimeters, and so our answer is D. Here we have 4 open bracket 3x minus y close bracket minus 2 open bracket 5x minus y. Now anytime you see the brackets, you have to remove the bracket, and we remove the bracket by using what we call the distributive law. And in the distributive law, it states that multiplication is distributive over addition and subtraction for a set of real numbers. So the first thing we need to do is to remove the bracket here. So you quickly can rewrite this 5x minus y, apply the distributive law by using the number outside here to multiply the contents on the inside. And here I am distributing the number outside to both terms on the inside. Now 3x minus y is a binomial expression. 5x minus y is a binomial expression. Binomial means it consists of 2 terms. So here, 4 will be multiplied to the 3x. 4 will be multiplied to the negative y. Now 2 things that you need to know in terms of directed numbers while multiplying and dividing. If the 2 signs are the same, then the product, if we are multiplying, is positive. And if the 2 signs are the same, the quotient when we are dividing is also positive. But if the 2 signs are different, the product and the quotient will be negative. So here, multiple choice. This time this, the 2 signs are the same. So you simply say 4 3s is 12x, because we must get the 12 positive along with the x. Here, the 2 signs are different, so we must get a negative. So you simply write down negative 4 times y is 4y. Again, this with this, 2 signs different, must get a negative. 2 5s is 10x. This with this, 2 signs are the same, we must get a positive. 2 times y is 2y. So quickly when you reach right here, you say, okay, we have x, we have y. These are unlike terms, but here we can group like terms. So we have 12x minus 10x minus 4y plus 2y. 12 minus 10 will give us 2x we owe 4. The minus in front here mean we owe. The plus can mean we owe 4. We have to pay what you have. Pay the 2, we still going owe 4. Still going owe 2, sorry. So here I have 2x minus 2y. But then you look up here to see if you see this. No, it is not seen. But then this can be manipulated. This actually can be factorized. Because 2 is a common factor. We take it out. And 2 cancels 2, leaving us with x. Minus 2 cancels 2, leaving us with y. Hence our answer is D. So you circle D. Now number 11. In the triangle PQR. So it's PQR. P here is a vertex, Q is a vertex, R is a vertex. Inside here is our angle, here is our angle, here is our angle. These are usually given capital letters. No, so in the triangle PQR, the ratio expressing tan of angle P. No, in trigonometry, basically we have 3 ratios that we can use. So we have the tan ratio, we have the sine ratio, and we have the cosine ratio. Now the tan ratio or the tangent ratio, because we have 3 sides of a right angle triangle, then we have what we call the opposite side, the adjacent, and we have the hypotenuse. Now only the hypotenuse is fixed, because the hypotenuse is always opposite to the right angle. So it's like, put your eye right here and look straight across. So this side must be opposite to the right angle. We call that the hypotenuse. Now, the adjacent side and the opposite side is dependent on the angle that you are looking at, or the angle that you really want to find. So here is our angle that we are now using, angle P. So this is angle P right here. Now, this side is adjacent to this angle. Adjacent normally means that which lie beside or next to. So clearly this is our adjacent side. And up here is our opposite side because it is straight ahead. So right up here is our opposite side. Now, if you are in the exam and you want to know the ratios, simply remember SO, CA, TOA. S stands for sine, C stands for cosine, T stands for tangent, O is opposite, H is hypotenuse, and A is adjacent side. So if it is tan of angle P, we look for T, which represents tan, which is opposite over adjacent. So as soon as you assign these sides, the opposite side is really RQ. So you write tan of angle P equals RQ here, which is our opposite side, over the adjacent, which is PQ. And then you look to see if your answer is there. So it's RQ over PQ, and then you circle C.